So let's say that I am standing at the origin, yes? If I take 2 steps in this direction, 1, 2, and then I take 3 steps in this direction, 1, 2, 3, what is my position on the number line? -1. So I took 2 steps in the positive direction, 3 steps in the negative direction. That gives me a position of -1. What was my total distance traveled? How many total steps did I take? 5. I took 2 that way and then 3 back this way. That's 5. Do you guys know what displacement is?
Yes.
What's my displacement? -1. The displacement is the distance or the difference in distance between where you started and where you finished. So if I started at 0 and now I'm at -1, that means I've got a displacement of -1. But total distance, you have to take into account everything. So now let's talk about velocity. Let me go back to 0 again. I walk this way. My velocity is what? Positive. Good. In positive direction, my velocity is positive. I have to stop to turn around. What's my velocity when I'm stopped? 0. And then now I'm walking in the negative direction. So in order to figure out total distance, I need to figure out where these stops are happening. I need to figure out where the particle is stopped so I can figure out how much or how far the particle has gone in each direction. Does that make sense? So we already actually figured that out for this example yesterday, yeah? We figured out that velocity was 0 at 1 and 3. Does that sound familiar from yesterday's example 1? We also figured out that acceleration was 0 at 2, but acceleration being 0 does not affect my particle stopping, so don't worry about including that one. All right, and there's only 2 more points I care about. I care about these 2 points. What would you call these 2 points? 0 and 5, which are here and here, but how would you describe them? Yeah, the initial and final. I'm going to call them the end points. So here are the points we care about, and I want you guys to circle these points on yours. We care about 0, that's the initial point. We care about 5, that's the final point. That tells me where I started and where I finished. We also care about 1, because the particle stopped and changed a direction at 1. And lastly, we also care about 3, because the particle stopped and changed a direction at 3. So our job, at 2, it does not change direction. It just has a constant speed, but it's not changing its direction. So the distances won't overlap. Our job is to figure out how far it went from 0 to 1, how far it went from 1 to 3, and how far it went from 3 to 5. And then add all those things together. So how do you think we're going to do that? Substitute the numbers into what? The position function. If we can figure out where it is at those moments in time, we can figure out how far it's gone. So let's figure out where the particle was at 0, at 1, at 3, and at 5. So we're literally going to plug in x of 0. Let's start with x of 0.
Oh, wow.
X of 0.
0 minus 0.
Yeah, 11. We get 0 plus 0 plus 0 plus 11. That's 11. X of 1, if I plug in 1, I get 1 cubed, which is 1, minus 6 times 1, that's minus 6, plus 9 times 1, that's 9, plus 11. What's that? 15. Good. X of 3. Notice I'm skipping over 2. 2 is not an important point for us in this graph. X of 3. 3 cubed, which is 27. 3 squared, that's 9. What's 9 times negative 6, class? 54. Negative 54, good. And then 3 times 9, which is 27, plus 11. So 27 plus 27 is 54. So that positive 54 minus 54 is 0, plus 11, which is 11. And last but not least, our last endpoint, the final position, x of 5. Is going to be 5 cubed, that's 125, minus 6 times 5 squared. So 5 squared is 25. 25 times 6 is negative 150. Plus 9 times 5, that'd be plus 45. And then plus 11. 125 minus 150, what is that? Negative 25. Negative 25 plus 45 is 20. 20 plus 11, 31? 31. All right, so here's what this means. At 0 seconds, I'm way over here on the number line at 11. In between 0 and 1 second, I managed to walk 4 more spaces in the positive direction. Now I'm at 15. In the span from 1 to 3, I walked back to 11. And then from 3 to 5 seconds, I walked forward again in the positive direction all the way to 31. So how much distance did I travel from 11 to 15? 4. So we're going to say this is 4 plus, what's the distance between 15 and 11? -4, good. So I'm just going to add the absolute value of -4. Because remember, we're trying to add together all the places I've walked, which means I don't want them to accidentally cancel each other out with negatives. And last but not least, what's the distance from 11 to 31? 20. So this is 4 plus -4 plus, I'm sorry, the absolute value of -4 plus 20, which is 28. So my total distance is 28. Something, whatever the units are for this problem.
Miles per second.
There you go.
Miles, like speeds per second.
Now, I also want to know displacement. I know this question isn't asking about displacement, but I also want to figure it out. So I want you guys to write displacement. And to figure out displacement, we only care about where we started and where we ended. We're going to subtract those two things. So we started at 11, we ended at 31. So the difference between 31 and 11 is 20 units. So my displacement is 20 units away from where I started. All right, we're going to work on one more of these. So when you're done with that, flip it over to the back. Let's look at example 2, number 4. All right. Example 2, yesterday we set the velocity equal to 0. When we did that, we got important points at 2 and 4. We also set the acceleration equal to 0 and got an important point at 3. What other points are considered important for me when I'm finding total distance? The 0 and 3. The endpoints are considered important. So I'm going to add 0 to my number line. That's going to be an important point for us. And then 3 is already there. Even though 3 wasn't necessarily important for velocity, it is now important because it's an endpoint. So we actually do not need 4 anymore since it's not in our interval. So we only care about 0, 2, and 3. But again, let's recap why. Why do we care about 2?
Because
Velocity was equal to 0, therefore it was changing direction. Why do we care about 0? That's where we started. Why do we care about 3? That's where we ended. We do not care about 3 because acceleration is equal to 0. We only care about 3 because that's where we end. So let's plug in 0, 2, and 3. See what we get. X of 0 is 0 plus 0 plus 0 minus 4, so -4. X of 2 would be 2 cubed, that's 8, so -8. 2 squared is 4. 4 times 9 is 36, plus 36. 2 times 24 is 48, minus 48, and then minus 4. What is that? Negative 24? I don't trust myself with arithmetic, so I let you guys do that for me. I know calculus like the back of my hand, but arithmetic, not so much. Adding? Oh, that sounds pretty difficult. I agree, negative 24. I'm just going to go off what you guys say. All right, x of 3, if I plug 3 into this function, we get 3 cubed, which is 27. That's negative 27. 3 squared, which is 9. 9 times 9 is 81. 24 times 3 is negative 72, and then minus 4. I believe you. But does Siri believe you is the question. I think it's negative 22 for those of you guys who are curious. So happy I got to that answer first. All right. So here's what this means. At 0 seconds, I was at a position of -4. At 2 seconds, I had walked in the negative direction. Now I'm at negative 24. Then back to 3 seconds, I go back to negative 22 again. So I had changed direction, and that had happened. How far did I walk from 0 to 2 seconds? In other words, what's the distance between -4 and -24? -20. Good, but distance is going to be the absolute value for total distance. So I'm going to say the absolute value of -20. Plus, how far did I walk from -24 to -22? +2. Good, +2 units. So the absolute value of -20 is +20, and then 20 plus 2 is 22. Now, that is total distance traveled. How about displacement? Good. Displacement is the distance or the difference between where I ended from where I started. So I ended at -22 and I started at -4. So -22 minus a -4, good, gives me -18. So my displacement is -18 units, but my total distance traveled is 22 units. Again, displacement. Ew. Who spelled that wrong? Displacement.
Jason.
There you go. Displacement. My bad. I just invented my own word. Displacement. All right, so again, the displacement is the difference between where you ended. We ended at -22 and where you started. So -22 minus the -4 turns into a +4. That's why it's -18. All right, we are going to move on to a different worksheet, if that's okay with you guys, unless you have any more questions for me. The data in the table below gives selected values for the velocity in meters per minute of a particle moving along the x-axis. Do me a favor and either circle or highlight that this is velocity. Now, in all the examples we've done so far, they gave you an equation for the position, and given the equation for the position, you were asked to find the velocity and acceleration functions. So, in this example, they are not giving you a table of values of the position, they're giving you a table of values of the velocity. So make sure that when we answer these questions, you are orienting your mind to realize that these are the values from the velocity function. It says the velocity v is a differentiable function of time t, and we're going to talk about what that means and why that's important in just a minute. Number 1, at time t equals 0, is the particle moving to the left or to the right? Do you guys see t equals 0 in the table?
Yes.
All right, what's the velocity at 0?
-3.
-3. What does that mean about the direction we're moving? We're moving to the left. Good. Because the velocity is?
0.
Negative.
Because the velocity is negative, we're moving to the left. So at t equals 0, is the particle moving to the right or the left? I want you to write left because velocity is negative. Number 2, is there a time during the interval from 0 to 12 minutes when the particle is at rest? And explain. I want you to talk about this with the people at your table before you tell me. So take a minute and talk about this question with the people at your table group. It says, is there a time during the interval where the particle is at rest? I want you guys to write yes. The particle is at rest, and I want us to put the interval there, is at rest in the interval between 0 and 2. So when 0 is less than t is less than 2. Because velocity equals 0. Or velocity, is changing sign. Velocity changes sign. Now, one of the things I want to make sure you guys do, always name your functions. So do not put because it changes sign. That's a very common mistake for people to say. They say because it changes sign. And I'm like, what's it? And then they're like, the velocity function. I say, why didn't you write that? And they're like, well, that's the only function they're giving us. Of course it's velocity. But that is not okay on the AP test. And it is not okay for your justifications in this class either. You need to specify which function you're talking about when you do. All right, let's look at number 3. It says use the data from the table to find an approximation for v prime of 10. Question, what is v prime? The derivative. Good, the derivative of velocity. And we're going to explain the meaning of v prime of 10 in terms of the motion of the particle. Question, can you guys do me a favor and either highlight or circle the word approximation?
When that happens to me, I just stop talking.
Anytime you see the word approximation in this class, it means that we're going to be using pre-calculus topics. So in this case, we're actually going to be using slope of, not a tangent line, but slope of starts with an S, secant. We're going to use the slope of the secant line. So here's how we are going to find... Here's how we're going to find v prime of 10. We need to find the slope between 2 points around 10. What points do you guys see around 10? 8 and 12. Good. So we're going to do y2 minus y1 over x2 minus x1. That's 5 minus 7 over 12 minus 8. 5 minus 7 is negative 2. 12 minus 8 is 4, which simplifies to negative 1/2. They want to know the units of measurement. What units are the... Meters per minute per minute. It starts with meters per minute as a y value, and our x value is minutes. Meters per minute is meters per minute squared. It also wants us to explain what that means in the context of the problem. What does that mean? Negative 1/2 meters per minute squared. What does that mean in the context of this problem? The acceleration, which is what?
v prime.
Good. But what does acceleration mean to you? How what? It's not how fast. Yes, it's not how fast it's moving. It's the rate at which the speed is changing, or the rate at which velocity is changing. So this is how quickly the velocity is changing.
So we don't say speed up, we say just a difference in velocity.
So it's not necessarily that we're talking about speeding up versus slowing down. They just want to know what the derivative is equal to. So the derivative is equal to the acceleration, and acceleration is how quickly the velocity is changing. But they're not actually asking us to figure out if it's speeding up or slowing down. All right, last question. It says, let A of t denote the acceleration of the particle at time t. Is there guaranteed to be a time in the interval such that A of c is equal to 0? Or in other words, that the acceleration is equal to 0? And justify. So I don't necessarily need you to graph it, but a graph will help us to understand it. I'm not going to graph these points perfectly, but they're approximately at these locations. 0, negative 3, 2, 2, 5, 3, 6, 5, 8, 7, and then 12, 5. And I know it's differentiable, which means we can connect it with a nice smooth curve like that. So this is a graph of velocity. This is v of t. What do you guys know about the relationship between velocity and acceleration? Acceleration is the slope of velocity. It's the derivative of velocity. They want to know if acceleration is ever going to be equal to 0, or in other words, if the slope of this line is ever going to be equal to 0. What do you guys think?
Yes. No.
What's the slope here? Positive here. Positive here. Negative here. 0. Does it have to be 0? If it's a nice smooth curve, does it have to be 0?
Yeah.
Yes. How do you know?
Because it changes direction.
It changes direction. It changes from increasing to decreasing. And from the table, you can see that. It's going up. Negative 3, positive 2, positive 3, positive 5, positive 7, and then it comes back down again. Back to 5. So we know that the velocity had to have a maximum at that point, which means it had to have a horizontal tangent line, a slope of 0. So the acceleration has to be 0 there. Yes. Because the velocity function is going up from negative 3 to 2 to 3 to 5 to 7 and then back down to 5 again, it had to turn around. And anytime that a nice differentiable smooth function turns around, it has to have a horizontal tangent line. So the slope has to be equal to 0 at that point, which means the acceleration has to be equal to 0 at that point. Yeah. So did anybody else have a question about that? Yeah.
So is acceleration always continuous?
If it depends on, there's some cases that it wouldn't be, but it depends what it is.
How do we know it's not going to continue?
Like, for example, if I drew this graph, if this was the velocity graph, and it has a vertical tangent. So yes, A of C equals 0. We're going to list an interval. It has to be between 6 and 12. It has to be equal to 0 somewhere in between 6 and 12 because it went from increasing to decreasing. So A of C equals 0 somewhere or in the interval from 6 to 12. So 6 is less than T is less than 12. Because, and again, don't use the word it, because velocity changes from increasing to decreasing.
So like on a test, we have to write all this down.
Uh-huh. Anytime it says justify.
And you're gonna test us like that?
Can I what?
You're gonna test us like that too?
Yes. All right, your turn. I want you guys to do the table one right below this.